An elevator problem. This one is tricky in a couple of different ways. One is that there are different objects that we need to write a free body diagram for in each part of this problem. So in part A, we're asked to figure out the tension of the cable of the elevator. So in part A, the object that we're looking at is the elevator with the woman inside, standing on the scale. So bathroom scale. And there's a cable that's pulling on the elevator. So there's a tension acting on all of this, and there's the weight of everything going down. So the mass here is going to be equal to the 50 kilograms of the person plus 750 kilograms of the elevator, so that's 800 kilograms worth in this object that we're interested in. Our force equation, sum of the forces is equal to ma. We don't need to worry about the x direction because there's nothing happening in the x direction. We just need to worry about the y direction. Because our elevator is moving downwards, I'm going to make down be positive. So if down is positive, my positive force is mg, and my tension will be negative. So mg is in the plus direction, t is in the minus direction, so this is going to be a minus sign in here. And that's going to be equal to ma. And we're looking for the tension, so if we rearrange this, I could add tension to this side, subtract ma from this side. That gives me mg minus ma. But I don't have a. So that's the next thing I need to do, is figure out what a is. They tell us that we're starting at a speed of 10 meters per second. We're coming to a stop. We do that in a distance of 25 meters, and we don't have a time. So the kinematic equation that's going to work is v squared is equal to v0 squared plus 2ay, which, if we solve for a, is v squared minus v0 squared over 2y. That's going to be 0 minus 10 squared over 2 times 25. Is going to give us a negative 2 meters per second squared. So that's by making positive go downward, that makes our v be positive. That means it's a negative acceleration since it's slowing down in that direction. So then now we can plug in, this is 800 times 9.8 minus 800 was our mass, and then times a negative 2. So I'm keeping the signs all consistent. Positive is still going down. When I do that, I'm going to end up with an overall tension of 9,440 newtons. On part B, we're now asked to figure out what the scale reads. So we've got this woman standing on a scale, and the forces that are acting on her are the weight going down and the normal force going up. The normal force is what the scale reads. So again, the elevator's moving downwards, so I'm going to make positive be down. The sum of my forces is equal to ma. mg is my positive force because it's in the positive direction, n is my minus force because it's in the negative direction, and that's equal to ma. And the normal force is what I'm looking for because I want to know what does the scale read. So then that's going to be equal to mg minus ma, which is 50 times 9.8 minus 50 times negative 2, and that ends up being 590 newtons. And life homework is to grab a bathroom scale and be in an elevator. I'm standing on it because you will watch it change. There are some videos out there that show that. I'll see if I can find one and attach it to the slideshow.